Alright friends, welcome back. In this video I'd like to go ahead and move on here in Chapter 2 by taking a look at Section 2.6 of your textbook, and this is going to talk all about how we combine functions together. Okay, and so if you hadn't had an opportunity to watch one of the last videos where we talked about what a function is, basically a function is a machine that takes in numbers that we call the inputs, and then the machine does something special with those inputs, and whatever the result of that is, we have that spit out of the machine, we call that the output. And there's some special notation that goes along with that, right? So if I feed the number x into my machine, and then the machine does what it does with the input, it's going to spit out the output. And the special notation for that is what you see here. It says f of x. Okay, so again, remembering that that does not mean f times x. That's just the name that we give the output that came from the input of x. So here in this video specifically, you're going to hear me use that language a lot because we are going to combine machines today. And so we might talk about the input of one machine and the input of another machine and really kind of stick to this notation. So this is definitely something that we're going to have to kind of stick to as we go throughout the video. So we're basically going to be constructing some new machines today. And so 4 classic machines that we can construct together are going to be your sum, difference, multiplication, and division machines, right? So these would be the machines that we get whenever we take 2 other existing machines, like maybe say your F machine and your G machine, and we take the outputs of them and add them together, subtract them from each other, multiply them together, etc., okay? We do have some unfortunate notation for that, in my opinion. This is the entire name of our new machine right here, at least as far as our sum machine is concerned. Again, the idea being there that we could introduce a letter in front, like S for sum, but the problem with that is that S already has a full-time job in the world of physics, and so we don't want that, right? This is your difference machine right here, and again, you might be thinking, well, can't we just say d of x for difference? Well, again, d of x has other applications in the world of physics and calculus, actually, so we actually don't want that. We have to kind of stick with this, unfortunately. F of g of x, can't we just call that like p for product of x or something like that? Well, p of x has a full-time job in the world of probability and statistics, so we can't have that. And then finally, definitely this one. I mean, come on, Mr. T, how weird does that look? Can't we just call that like q of x for like quotient? Well, again, in the world of probability and statistics, q of x already has a full-time job, unfortunately. So here we're just going to have to unfortunately stick with these names here. But the most important part here is what they are defined to be equal to, which is going to play very well with your common sense, right? If I'm doing my sum machine of f and g, then that means I just take the output of f plus the output of g, and that's how I get my output in this new function. If I'm doing my difference machine, then I'm just going to take the outputs of my 2 other machines and subtract them. Very, very easy to do. If I'm doing my multiplication machine or my product machine here, then same thing. I'm just going to multiply the outputs of f and g, and then again, similarly, if I'm doing my division machine, I just go ahead and divide the outputs here, making sure to include this note that this is something I'm allowed to do as long as what I'm dividing by is not equal to 0, which is a note that we've had to kind of tack on in a lot of different cases throughout the semester when we've been dividing by certain quantities here, okay? So what I want to do for the rest of the video here is just go ahead and give you some exposure to some of these examples, right? This should all be stuff that you've talked about in a previous algebra course, but here we're just going ahead and reviewing these concepts. You'll notice that I'm giving you 3 functions to start, so these are 3 machines that are already built. You've got your F machine. Really quickly, I just want to kind of describe what it does. It's going to take your input, it's going to take that number that you give the machine, and it's going to do what with it, okay? Well, this is the machine that's programmed to double your number first and then add a 1 onto that. Okay, and so again, you can probably come up with a couple of different examples in your head of you feeding a number into this machine and then figuring out what this number would give you back. Okay, you also have your G machine here. It looks like this is a little bit of a quadratic, but this is going to take the number that you give it and square it first and then add on 2 times the number you gave it and then subtract a 1, and whatever that result is, that is going to be the output. In this third and final machine here, this is your H of x machine here. This is simply going to take the number that you give it and take 1 divided by the number that you gave it and then spit out whatever the result is as your output, okay? So we have these 3 distinct machines here, and what we'd like to go ahead and do is construct some new machines. And so you can see here in number 1 that we just want to go ahead and construct our sum machine. We're going to do that by definition, right? So this was just defined to be taking the output of F machine plus the output of G machine. Okay, and so the output of F machine, we know what that looks like. That's just right up here. Okay, so that was our machine that took our input and doubled it and then added 1. And what we need to do is take that output, which you'll notice I'm going to go ahead and signify that that's one quantity by encasing it in a set of parentheses there. I'm going to add that to the output from G, which again is right up here, right? So the output from G is you square the input and then add on 2 times the input and then take away 1. And there we go. Okay, so that's us setting the problem up for ourselves. But what we now need to go through is actually perform that addition, okay? Perform that sum in between them. And the way that you do that is you simply combine like terms, right? So I have an x squared term there that does not have any other like terms to combine with, so I'm going to write that out front. I have a couple of x terms here. I have 2x plus 2x, that makes 4x. And then when you move on to your constants, you'll notice that you have positive 1 plus negative 1, and that simply makes 0. So I'm not going to add a plus 0 at the end there. I'm just going to go ahead and box that as my result right there, okay? Same thing when it comes to your difference machine. We're going to use the definition of your difference machine, which is just simply take the difference of your 2 outputs from your 2 machines. So set up very similarly, we're just simply going to have 2x plus 1 minus x squared plus 2x minus 1. And this is why it's particularly important to go ahead and put this stuff in sets of parentheses, because if you didn't, then you might have missed the fact that what we now have to do in our next step is distribute this minus sign to all 3 terms of g of x, okay? And that is going to change some signs on us here. So writing this all out, you're going to have 2x plus 1 minus x squared minus 2x plus 1. And then after that, it's just a matter of combining like terms. I'm going to go and write this in standard order. So negative x squared comes first. Then we have 2x minus 2x. That just simply makes 0. So those are going to cancel out of the problem here for us. But then we have those constants to go ahead and combine. So 1 plus 1, that of course makes 2. And so this gives us a nice function formula for our new machine. Okay. Again, those are pretty straightforward. The only recommendation that I have for you, again, is to just make sure that you go ahead and encase this stuff in sets of parentheses so that you don't make any mistakes when it comes to sign rules and that kind of thing. You notice that I did these next couple of examples here for you. Number 2, I'm doing my product machine. I'm taking the output of f times the output of h. I'm just multiplying those together, and you can see that that's the result there. One of the things that I should have done on that one is included a little bit of a note, because since I'm dividing by x, I should have said I can do this as long as x is not allowed to be equal to 0, since that's a quantity that I'm trying to divide by. So I'll encase that in my answer box, right? And then in number 4, we're doing our division machine. So I'm taking the output of f divided by the output of h. You notice that I just simply set that up as 1 over the other. And then again here, because I am taking the division by a fraction, I can go ahead and rewrite that as the multiplication by the reciprocal. That's a concept that we've talked about a couple times this year. So that's something that we can go ahead and apply here whenever we're trying to find this new output, okay? A couple more here. Number 5, it looks like I want to go ahead and take the output of g and the output of h after doing an input of 3 and then multiply those together here. So again, going back to the definition, this is g of the input 3 times h of the input 3. And what we're going to find here is that because we actually have a value to work with here, we're going to end up with an answer that is a value as well. Okay, so we're just going to have to go ahead and reach for those machines. The G machine, of course, was the one that went ahead and squared the input and then added on 2 times the input and then subtracted a 1. What is our input? Our input, of course, is positive 3. So we're just going to go ahead and plug that into my G machine there, and we're going to get that result here. That is going to end up being 3 squared is 9, plus 2 times 3, that's 6, so that'll be 15. Take away 1, that'll, of course, be 14 there, okay? What we're going to now have to do, since that's the output of G, is we're going to have to go ahead and multiply that times the output from H. And if you remember your H machine, that was your machine that was defined to take your input and then say 1 divided by that number. What is our input? Well, of course, our input is 3. So we're going to take 1 divided by that number 3, and we're going to see here that we're just going to go ahead and simply have a 1/3, okay? So the problem is done whenever you've gone ahead and multiplied the 2 outputs from G and from H, and here that's just a 14 times 1/3. That is just going to simply be an improper fraction here, 14 over 3, as our final result. And finally, number 6 here, this is another similar example to the one that we just talked about, except here you're taking the outputs from G and H and adding them together after making your input a positive 4. So you could see that here, right? So in my G machine, I'm just plugging in a positive 4 as my input, and then I'm seeing here that the output actually turns into a 23. When I plug 4 into my H machine, it took 1 divided by 4, and that gives me a 1/4 there. And if you add those two, you're going to have to find a common denominator. You could let the TID4 do that on your own, but that's going to give you the improper fraction 93 over 4. So just a little bit of review about how we evaluate functions and how we start to go ahead and make sense out of combining 2 functions together. We just go back to those very simple definitions and tack notes on whenever we need to. Another type of a combination of two functions is this idea of function composition, okay? And so this is something that is going to involve a little bit of thinking. I want to go and draw you a picture so that you can make some better sense of this. So we have two machines here. We have a G machine and we have an F machine. So let me go and draw those, right? So I have a G machine here, which I'll go ahead and color blue. So this is my G machine. Again, it takes in inputs and spits out outputs. And what we might say here is that this machine is going to take in X, and we know according to our notation that what it spits out as the output is what we call G of X. The whole concept of a composition of two functions is that I am now going to take that very same output that I got out of my G machine, and I'm going to throw that into an entirely separately new machine here, right? So I'm going to go ahead and throw that output into this other machine here, which I might call my F machine, okay? And so when I do that, we have that notation that says if what you give your F machine, like say we gave this a value of A, we know that the notation would be F of A. So whatever it is that you give it, it's going to be F of that. Well, what we are giving it is the entire output from G. That's going to be G of X that we're giving it. And so spat out from this thing is going to be something that we'll write with our notation here. We'll say F of G of X. So maybe using some color there would help us make some sense out of that, right? So this is G of X coming out of my blue G machine after plugging in X, and then we're plugging that blue G of X into my red F machine, and we're getting F of G of X in that way. And so that's what this is right here. This is F of G of X right there, and we have some special notation for that output. We use this little circle symbol in between. That's your of symbol. So the way that you literally read that off the page is you would literally read this as F of G, or you could say F composed with G, okay? I think you'll catch me typically saying the second one, F composed with G, because again, that gives across this idea that I took my output from G and I threw it right into my F machine and got the corresponding output out of that F composed with G, okay? So one of the things that is particular about this is since we took the output of G and threw it in as the input of F, that we're going to always find here that the range of your G machine is going to be exactly equal to your domain of your F machine, okay? Again, your range is that list of all of the X values, your range is all of your Y values, I should say, and your domain is all of your X values. Well, you got to keep in mind that I'm taking my output from my G machine, so something out of its range, and I'm throwing that in as the input of my F machine, so that's a part of its domain, okay? So that's something to kind of point out here. So whenever we're taking a look at examples here, we're going to go ahead and keep in mind that special notation and how we go ahead and combine these functions together. So let's go ahead and do that here, right? So number 9, it says F composed with G of X. And so the way that I kind of like to do this is to write it out, right? So I've got F of something. What is that something? That something is the output of G. Okay, so I'm looking at my G machine and I'm looking at what it is programmed to do. Well, my G machine apparently is programmed to take in the input and square it and then subtract a 7. And so that is what I'm plugging into my F machine. So in the next line down, I'll say that. I'll say F of my input. What is my input? Well, my input is the output of G, and that was X squared minus 7. Okay, so I now know what I'm throwing inside of my F machine. I now need to just remind myself what my F machine actually does. Okay, well, my F machine, if you look up here, this is the machine that's programmed to take whatever you get it and triple it and then add a 1. So it's going to take whatever I gave it and multiply it times 3 first, and then it's going to add a 1. Well, what am I giving it? I'm giving it X squared minus 7. That's the output of G. And so basically you just kind of set yourself up here for being able to simplify this algebraic expression, and the steps for that are pretty straightforward. We're just going to go ahead and distribute in a 3 first, so that'll be 3x squared minus 21 plus that 1 that's at the end, and then we'll just combine any like terms that we might have. So I have that negative 21 plus 1, and so here that's going to be 3x squared minus 20 as our final result. So that is F composed with G of X. In the next example here, number 10, it's the exact same thing. You'll see the exact same work here, except now I'm just looking at G and H. And there is an order there, right, that we need to be paying attention to. So this first machine here, that is going to be the outermost one, and the second machine listed here, that's going to be the one that we plug into the other. Okay, so we got to pay attention to the order that these are written as. Okay, so some other machines here. So we have these basically these same ones here, right? We now need to go through and do H composed with F of 1, okay? And so, again, going back to the definition here, we're taking h composed with something. We're going to give something to h, the input, right? What is the input? Well, that is going to be the output from f after inputting in a 1. Okay, so that's what that 1 is doing right there. That's playing the role of our input of this, right? So one of the first things that we should figure out is what's going to happen if we give our f machine a 1. Well, it's simply just going to take 1 and plug it in for all the x's that you see. So that'll simply be 3 times 1 plus 1. And if you do some mental math on that, you might realize that that is simply just going to be a result of 4. And so what I'm really giving my h machine is simply the number 4. And if I review what my h machine does really quickly, that's just my square root machine. This is just the machine that's programmed to take the square root of whatever I give it. I'm just going to do simply the square root of 4 here. And we know what that result is. That's simply going to be a 2. And that represents our final result for that example right there. Okay, so be on the lookout for if it says something like, f composed with g of x, or if it says, something composed with something else of an actual value, like 1. That means that you're going to end up with an output that's a value itself. As weird as this might seem, we can actually compose a machine with itself. So to draw a picture of that, right, that would be interpreted as taking this f machine here. And what you do here is you first feed it an x, and we, of course, know that what we get out of that is f of x. But then what we do is we take that f of x that we just got out, and we loop it all the way back around, back into the machine, so that we get f of x, or what we might write as f circle f of x, okay? And so we're basically just kind of looping it back through twice in this case. And so you can see that the work pans out the exact same way. I'm still taking my output from f and plugging it in as the input all the way back over again, looping that back around. And I just simplify the result here after doing some distributive property and combining of like terms. I get 9x plus 4. Here in this next example here, this is just g composed with h of 2. Again, another example where I'm just taking h of 2, I'm figuring out what that output is, and I'm making that the input on my g machine, okay? And you'll see that the way that this works out is that the output from h after plugging in a 2 happened to be the square root of 2, but then when I plug that result into my g machine, the g machine has this operation of an exponent of 2, and remember that's something that actually undoes that square root. And so that just simply leaves you with the 2 that was inside, and so now we can go ahead and simply do 2 minus 7, and that gives us a result of negative 5. So number 14 here, we actually have a multiple composition here, and here it's going to be the exact same definition as always. We just need to be careful about the order, because we said that the one that appears the furthest to the right, that is the innermost function that we're going to do here, right? So let's just go ahead and work with this, right? So we first see f of something. So we'll say f composed with something. We're going to give something to my f machine of g. So that's going to be of g of something. And then finally of h, right? So that'll be h of our input, which looks like here is simply just going to be 2a. Okay, so I'm going to use this color as we go through here. Hopefully that works out for you guys here, but let's just go ahead and figure out what that is. We're going to work from the inside out. So just reminding ourselves what our h machine does, that was our square root machine, okay? And so in place of h of 2a, I'm going to go ahead and say the square root of the input, 2a, okay? That's something that we are giving my g machine, and then whatever the result of that is something that we are giving our f machine. So we're just going to do one thing at a time. So we're just now going to go ahead and remind ourselves what our g machine does, and that, of course, was our machine that takes our input and squares it and then subtracts a 7, okay? And so we're going to go ahead and say that here. We're going to say that our g machine in blue, that takes our input and squares it and then subtracts 7. What are we giving it? Well, we are giving it that square root of 2a, and then whatever the result of that is, that's something that we are plugging inside of f, okay? And so the square root and the exponent of 2, those undo each other, just simply leaving us with 2a. And then remember the G machine continues by subtracting a 7, and that is going to be an expression that we're going to have to plug into f. We're calling what our f machine does here really quick. Our f machine was that machine that triples our input and then adds a 1. And so this is going to be the machine that takes whatever we gave it and multiplies it by 3 and adds 1. What did we give it? Well, we are giving it 2a minus 7. Okay, and so here is where we can just go ahead and do some quick distributive properties. So distribute that 3 inside. So 6a minus 21 plus 1, and that is simply going to reduce down to 6a minus 20 as our final result there. So that is as complicated as things are going to get, and that's just because we have a whole bunch of like functions within functions as inputs and outputs and that kind of thing. But hopefully the color works out for you there. And again, if you guys have any additional questions, as always, feel free to let me know. The last example that I want to discuss in this video is how to do the reverse, right? So how can you decompose a function instead of composing one with the other, right? So here it does say f of g, so that is the order, right? So I might stick with some coloring here. I might say f of g of x. Okay, and so what we're looking for here, when you're looking at this function formula, it says here the cube root of x plus 5. We want to look for an innermost function and then an outermost function. And from example to example, there could be multiple different ways that you interpret this, but I think an easy way to interpret this one would be to say that on the inside, I've got that expression x plus 5, and then on the outside, I've got this operation of the cube root of 3. So one way that I could interpret this is by saying that f of the input is equal to the cube root of the input. And then I could say separately, my g machine is g of the input is equal to the input plus 5, right? And so it's just kind of taking a look at what you have and looking at it as what is my innermost machine and what is my outermost machine. But this would be an example of how to decompose a composite function. Okay, but that's all I have for this video here. So just doing various compositions and combinations of different functions here. Hopefully this all makes sense. If not, then feel free to come see me in the live chat. But that's all I have for this one. Thank you very much for your attention, and I'll speak to you in the next one.